Good evening, my dear viewers of Akshi.com by Vetri from Pondicherry. Today, I am going to discuss another most important chapter in chemistry, that is thermodynamics. So, I am going to give this under this a basic introduction to thermodynamics. A few years back, the same chapter was given in the form of energetics in higher secondary books in Tamil Nadu syllabus. Okay, let me enter into this thermodynamics. What is thermodynamics? Thermodynamics is a branch of science that it deals with quantitative relationship between heat and work, and also interconversion of one kind of energy into another form of energy in the universe. This is called thermodynamics. Let me repeat again. Thermodynamics is a branch of science that deals with quantitative relationships between heat and work, and also interconversion of one kind of energy into another form of energy in the universe. That is called thermodynamics. Okay. Now, before entering into this, the most important law is called the law of conservation of energy. You must understand in order to understand thermodynamics. What is the law of conservation of energy? Energy can neither be created nor destroyed, but it can be converted from one form to another form in the universe. This is called the law of conservation of energy. This is the most important. Let me repeat again. Energy can neither be created nor destroyed. We cannot create, we cannot destroy. But it can be converted from one form to another form in the universe. This is the most important fundamental law connecting thermodynamics. Okay, here it is most important you must know. That is, it is noteworthy that all forms of energy can be completely transformed into work. All forms of energy can be completely transformed into work. But heat cannot be completely converted into work. This is the most important point you must keep it on your mind. Let me repeat again. All other forms of energy can be completely transformed into work. But heat cannot be completely converted into work. Okay. So in order to understand thermodynamics, what are the thermodynamic terms you must be familiar first? So what are the terms I am going to discuss in this thermodynamics? Well, let me call it thermodynamic terms. You must know what is universe. Number 2, system. Number 3, surroundings. Number 4, thermodynamic properties. 5, process. Then internal energy and change in internal energy. Enthalpy and change in enthalpy. The terms continuous. Heat capacity. Laws of thermodynamics. 0th law, 1st law, 2nd law, 3rd law. Laws of thermodynamics. Entropy. And finally, gives free energy. So these are the important thermodynamic terms you must know to understand the thermodynamics. So let me discuss one by one. Then I will go for the laws of thermodynamics. So in order to understand the entire process of thermodynamics, so we must know what is universe, what is system, what is surroundings. And systems, depending upon the conditions, there are 3 types of system. One is open system, another is closed system, and third is isolated system. So let me explain with a suitable example, you understand. What is universe? Just now I informed you, a system and its surroundings are called universe. A system and its surroundings are called universe. So universe is nothing but a system and its surroundings. Very, very simple. What is a system? Then automatically it consists of 2 things. One is system, another is surroundings. So both we are calling it as universe. Okay, what is system? Any matter under investigation is called system. Any matter under investigation is called system. Suppose I want to study about this pen. So the pen is a system. So I want to study about a particular beaker, a conical flask, anything. So that particular object, any matter under investigation is called the system. The other interesting information is the state of a thermodynamic system is described by its measurable property. This is the interesting information. So let me go in detail later. So any matter under investigation is called a system. So this system I can classify into three types. I have already pointed out: open system, closed system, and isolated system. What is an open system? Let me call it as. An open system is one from which mass and the energy can be transferred to surroundings and vice versa. An open system is one from which mass and the energy can be transferred to the surroundings and vice versa. This is the most important. A specific example, you conduct a chemical reaction in an open beaker in the laboratory. So consider the chemical reactants in the beaker is considered as an open system. So when you are conducting a reaction, if any gas is formed, the gas will go to the atmosphere. The temperature will be affected. Again, heat will be transferred from the system to surrounding. The energy and the interesting information is, open system is one from which mass and the energy can be transferred from system to surroundings and surrounding to system. So any system behave like this, we will call it as open system. Any chemical reaction taking place in a open beaker, open vessel in the room temperature, we will call it as open system. This is the very, very interesting information. Okay, next. What is a closed system? A closed system is one from which energy but not mass can be transferred to surroundings and vice versa. A closed system is one from which energy but not mass can be transferred to the surroundings and vice versa. The idea here is, in closed system, only energy can be transferred but not mass because the vessel is closed. Same specific example here. Again, take a closed vessel, closed beaker, where you take any reactant and conduct any chemical reaction. It is closed. So any gas, if it is liberated, will not be allowed to move into the atmosphere. So it is closed. So mass is not allowed to escape to the surrounding, but energy it can conduct, it can move from the system to the surroundings. So a closed system is one from which energy but not mass can be transferred to surroundings and vice versa. This is called closed system. Okay, let me go for isolated system. What is an isolated system? An isolated system is one from which neither mass nor energy will be transferred to surroundings and vice versa. So, an isolated system is one from which neither mass nor energy will be transferred to surroundings and vice versa. So that means, again a specific example, you conduct any chemical reaction in a thermally insulated closed vessel. Thermally insulated closed vessel, if you conduct any chemical reaction, so from that particular system, neither mass nor energy will be transferred to the surroundings. Same way, from the surrounding to the system. So this is the specific example of isolated system. Kindly follow. So a system, three types: open system, closed system, and isolated system. So whenever you are studying any chemical reactions or any process, kindly have it in mind what type of system is indicated. Is it an open system? Is it a closed system? Is it a thermally insulated isolated system? This is the most important information you must know. Okay, and next let me tell you, what is surroundings? Except the system, all the remaining things in the universe are called surroundings. Except the system, all the remaining things in the universe are called surroundings. So I have already explained a system and its surroundings are called the universe. I have explained what is a system. Suppose we are having a vessel, open or closed or isolated, having a reactance. Except that system, all the remaining things surrounding that, we'll call it as the surroundings. So system and surroundings are called universe. So this is the idea you must have first, because we are going to study entire process thermodynamics between a study of system and surroundings only we are going to study. So kindly have it in mind. Next, let me go for the next one, properties of a system. This is another interesting concept, the term you must know. What is a property? Suppose you take a gas. A gas, so when you are taking gas, normally we will take in a vessel, closed vessel. And when you are keeping in a closed vessel, we have to specify the state. What way? What is the volume? What is the pressure it has? And what is the temperature it has? So, the state of a system we can now specify by the property, variables. So that we'll call it as properties of a system. It may be temperature, it may be pressure, it may be anything. So a state of a system can be changed by changing any one of the property. Okay. Now I can classify the entire properties of system by two ways. One is based on mass I can classify, and another is based on nature I can classify. So first let me discuss based on the mass I can classify the properties of system, thermodynamic system. What may? So based on mass, I can classify the entire properties of a thermodynamic system into two types. One is intensive properties, another is extensive property. So we can raise a question. What is intensive property? What is extensive property? Because the competitive question can be asked. One among the following is an intensive property. One among the following is an extensive property. They can give example. Or directly they will give density in an example of like that. They can. The idea here it is, what is intensive property? Let me define now. Intensive property of a system is one which is independent of mass. So any property which is not depending on mass, we'll call it as intensive property. Very, very interesting. Any property which is not depending on mass, we'll call it as intensive property. So automatically, what is the extensive property? Any property which depends on mass, we'll call it as extensive property. This is the very interesting information. The same way I am going in detail each property. So based on the nature I can classify into two types. One is state property, another is path property. Any property which depends on only state, initial state and final state, state property. So any property which depends only on path, we'll call it as path property. So let me give detailed information with the example I will discuss. First, let me concentrate on intensive property. What is intensive property? Just now I have decided. Any property which is not depending on mass, which is independent of mass, is called intensive property. Specific example, density is an intensive property. Specific gravity, viscosity, refractive index, all these examples are intensive property. So let me take a specific example of density and I will explain why it is not depending on mass. So what is density? Kindly follow. Density equal to mass by volume. Mass by volume. That is the density. So when you come for mass by volume, it is density. Okay. Now, coming further, suppose I want to determine the density of water. So what I will take, let us assume now I will take 10 ml. Assume 10 ml I am taking. Assume now the 10 ml of water, mass of 10 ml of water is, assuming that it is 10 gram. So what I will do, 10 grams divided by 10 ml, the corresponding density I will call it as 1. Density of water is at a particular temperature, room temperature 1. Suppose if I take 100 ml of water, again mass will be 100 grams, volume will be again 100 ml, again 100 by 100, again 1. So whether I was taking 10 ml or 100 ml, whatever I take, the density will be 1. So density is independent of mass. The same way I can say specific gravity, viscosity, refractive index. The interesting point is any property which is independent of mass is called intrinsic property. Kindly follow. The next one. Extrinsic property. I have already explained you. What is extrinsic? Any property which depends on mass. Is called extrinsic property. So important extrinsic properties that we are going to study under the thermodynamics. 1. Temperature. Usually divided by T. Pressure. P. Volume. Internal energy normally indicated E or U. So normally in CBSE book we are using only U for internal energy. Enthalpy H, capital H. Entropy S. And free energy gives free energy G. So all these properties are extrinsic property because these properties are depending on mass. This is the interesting information I want to give here. Okay, next one. State property. Just now I explained you. That is, but this is based on the nature. What is the state property? Now, normally when you say state means you have to assume this way. Let me say this way. Any matter, when I was discussing in the first class, I have given a very clear idea. Matter can be classified basically 2 ways. One is based on physical property, another is based on chemical properties. So based on physical properties, I can classify solid, liquid and gas. So this corresponding state I will call it a solid state, liquid state and gaseous state. So suppose I am taking an atom of water. At 100 degree when all the liquid in this liquid state is converted into gaseous state. So I can say liquid means I will say initial. If you assume, then gaseous will be the final state. So initial state and final state. So this is the way we have to assume. So state property. Any property which depends on state, initial and final state, that we'll call it as the state property. Temperature, one other state property. Pressure, another state property. Volume, state property. Internal energy, state property. Enthalpy, state property. Entropy, state property. And gives free energy, state property. So these are the state properties. Okay, let me go for the next one. Path property. Next one. What is path property? Any property which depends on path. Not initial and final, that is in between, path. Any property which depends on path is called as path property. Important example under this, work is a path property, heat is a path property. Kindly have it in mind. Okay, with this idea, let me go for next. So, what I have discussed so far, what is the property? What are the way we can classify the properties I have discussed? So, whenever say a system can be from one state to another state, it can be changed by changing based on the variables or property. So when we are changing one state from one state to another state, we are following some process. So what are the process? Now I am going to discover types of process. What is the process? Let me define. What is the process? Whenever a system changes from one state to another, whenever a system changes from one state to another state, solids to liquid state, liquid to gaseous state, like that, gaseous to solid, whatever it is. So whenever a system changes from one state to another state, it is not necessarily solid to liquid, liquid to gas, gas to solid. It may be even liquid means from one temperature to another temperature, initial state and final state. So that also you must have it an idea. So whenever a system changes from one state to another state, it changes its property. What way? By changing any one of its variables or properties. Temperature, pressure, volume, energy, enthalpy, entropy, free energy. So by changing any one of its properties through different process. So this is called, we'll call it as process. Whenever a system changes from one state to another, it changes the property by changing any one of its variables or property through a different process. What are the different process we have to study under thermodynamics? Now, so I can classify again the process by 2 ways. One is based on the condition I can classify, based on the direction I can classify the different process that we are following in thermodynamics. Based on condition, I can classify the processes are into 4 types I am going to discuss. One is isothermal process, adiabatic process, isochoric process, isobaric process. This is the very, very interesting information. So based on the conditions, I can classify the process into 4 types: isothermal, adiabatic, isochoric, and the isobaric process. The same way, based on the direction, I can classify a reversible process, irreversible process, and cyclic process. Also, I can classify. Okay, let me discuss with a suitable example. So first, let me take what is an isothermal process. Iso means same, thermal, temperature. So same temperature. Very clear idea now you must have. So isothermal process is one where temperature is kept constant. Very, very interesting. Isothermal process is one where temperature is kept constant. That is delta T equal to 0. This is the very, very interesting information. So if you want to understand this, let me give a clear idea. Suppose now, let me say this is system A. Now, the system now in state A, let us assume state A. Now the temperature, again, the pressure is P1, volume is P1, the V1, and temperature is P1. Let us assume this is a gas. A is a gas. It is now having a pressure of P1, volume V1, and temperature T1. So if I am changing this gas A to one state, A state to B state. So what I am doing now? I am changing the pressure as P2. Volume I am changing to V2, but I am keeping the temperature as same 1, T1. Or let me say this way, if I am conducting any chemical reaction at room temperature, so automatically then temperature will be constant. So pressure and volume changes in the case of gases. So that system, that process is called isothermal process. Very, very interesting information. So isothermal process is one where temperature is kept constant. Delta T will be 0. This is the interesting information. The next one. Coming for adiabatic process. Adiabatic process is one where energy is neither absorbed nor released. Neither energy is absorbed nor energy is released. That is delta Q equal to 0. This is the most important. Let me repeat again. Adiabatic process is one where energy is neither absorbed nor released. Delta Q equal to 0. I have already explained. That's a system and that's a surrounding. So when the system is not absorbing any energy from the surroundings or it is not releasing any energy from the system to surrounding, if you conduct any process, that process will be called adiabatic process. Or simply I will say delta Q will be 0. This is the very, very interesting information. The next one. Isochoric process. What is isochoric process? Isochoric process is one where volume is kept constant. Very, very interesting. Volume is kept constant. That is delta V equal to 0. That means here the interesting information is consider the system is a closed vessel. Kindly follow. Suppose we have a vessel, closed vessel, and if you are having a gas inside, and if you are conducting any experiment, so now we can assume now it is the corresponding volume is kept constant. That is isochoric process, that is delta V equal to 0. This is very interesting information. So isochoric process is one where the corresponding volume is kept constant. Now, next one is isobaric process. What is isobaric process? Isobaric process is one where pressure is kept constant. Isobaric process is one where pressure is kept constant. That is delta P equal to 0. So in both cases, initial and final state, the pressure is kept constant. So let me say, whenever we conduct any chemical reaction at 1 atmospheric pressure, that particular process is called isobaric process. So this is the very, very interesting information I want to give. So the process, depending upon the process, now the condition we are following, we can call it as either an isothermal process, or adiabatic process, or isochoric process, or isobaric process. This is based on the property. Let me go for the next one is, based on the direction I can classify the process. I have already explained to you there are three: reversible process, irreversible process, and cyclic process. Let me come for a reversible process. What is a reversible process? A reversible process is one where initial and final states are in equilibrium. Kindly follow. It is based on the equilibrium. Reversible process one where initial and final state are in equilibrium. That process is called a reversible process. Very, very interesting information. So this is possible when changes are taking place slowly, very, very slowly. Specific example, conversion of ice from water and vice versa. Conversion of ice from water and vice versa. This is a specific example. We'll call it as a reversible process. Okay, the next interesting. Irreversible process. What is irreversible process? Irreversible process is one where the initial and final states are not in equilibrium. Kindly follow. Irreversible process is one where the initial and the final states are not in equilibrium. They are not in equilibrium. So that is called irreversible process. Many of spontaneous processes are irreversible in nature. Many of the spontaneous processes are irreversible in nature. Specific example, water flowing from a hill. It is an example of irreversible. Raining, it is irreversible. This is the interesting information for a irreversible process. Next one, finally, cyclic process. What is cyclic process? Cyclic process is one where a system will come back to its original state after series of changes. This is very, very interesting information. Cyclic process is one where a system will come back to its original state after series of changes where delta U equal to 0. So whenever delta U equal to 0, the corresponding process will call it as cyclic process. This is very, very interesting information. Okay, so these are the different types of the process you must know to understand. Next, let me go for the change of state of system. How a system can change its state from one state to another. Let me call it as from lower temperature to higher temperature, from lower volume, higher volume, lower pressure, higher pressure, or even state, solid to liquid, liquid to, so all these state. So how a system can change its state? So it can change the state by doing work, by absorption of heat or release of heat, and absorption of energy or release of energy. So this is the very, that is, energy means we'll call it as internal energy. Let me discuss here. First one, let me concentrate on work. Kindly follow, this is actually in physics you will be studying under this mechanics. Now let me give a simple definition here. Work, what is work? Work is defined as the product of force and the distance of displacement. Very, very simple definition. Work is defined as the product of force and the distance of displacement. We will call it as work. So I can give mathematically W equal to F into D. So W, work. F, force. D, distance of displacement. Okay. So this is the general definition for any work. But I can classify work by three ways. One is gravitational work, another is electrical work, and third is mechanical work. So what is under the gravitational work? So W, gravitational work, instead of F into D general term, I can now specify mgh. M mass, G gravitation, H height. Or that is correspondingly mg is nothing but force into height. This is for work for gravitational. The same way for electrical work, that is nothing equal to Q into V. Mechanical work, nothing but P into delta V, pressure into change in volume, P into delta V. So, this is work. So, this is the definition for work and different types of work. So what is the sign convention of work? This is the most important, kindly students kindly have it in mind. So when we are studying the laws of thermodynamics, first law, and some books, different books will give different version, the mathematical form. So I will be explaining later, but kindly have it there. So in order to understand the thermodynamics law, first law specifically, you must have it in mind that carefully analyze the sign convention we are using for work. So for work, sign convention, so I am going to use two things. One is, if any work is done by the system, work will be always negative. So work will be expressed negative. Kindly follow. The sign convention we are using negative for work is done by the system. Whereas work is done on the system, compression, work is done on the system, W will be positive. This is the very, very interesting information. So a simple example, work is done by the system means expansion of gas. Work is done on the system means compression of gas. Very simple. So the idea here it is, the sign convention of work is done by the system, W equal to negative. Work is done on the system, W equal to positive. This is the sign convention we have to use in thermodynamics. Coming for heat. Characteristic of heat. This is the most important. What is the characteristic? Heat is an algebraic quantity. This is the most important characteristic of heat. It is an algebraic quantity. Number two, it is a path function. Heat is a path function. It's not a state function. The third important, due to temperature changes of the system, this is the taking place. Heat transfer taking place. This is the very, very interesting information regarding the characteristic. What is the sign convention of heat? This is another interesting information. Students, you must keep it in your mind. Sign conversion of heat. Now, heat is absorbed by the system. Q equal to positive. Kindly follow. So consider a system and there is surroundings. If any system is absorbing heat, Q will be positive. That is, heat is lost by the system, Q will be negative. This is the interesting information. So heat is absorbed by the system, Q equal to positive. Heat is lost by the system, Q equal to negative. Kindly follow. This is the most important information regarding the sign convention of heat. Okay. Let me go for the next one is energy. This is another important term. Energy, when I say, I can say two ways. One is internal energy, another is enthalpy or heat content. Sometimes I will use heat content. Internal energy or enthalpy. Okay. What is internal energy? What is internal energy? The energy stored in a substance by virtue of its constituent particles. The energy stored in a substance by virtue of its constituent particles. Particles may be atoms, may be molecules. Is called internal energy. Can you follow? Let me repeat again. The energy stored in a substance by virtue of its constituent particles, atoms or molecules is called internal energy. The internal energy is usually represented by capital E or capital U. So I am going to use throughout my discussions, I am going to use capital U because it is followed in all CBSE books, capital U. If you go for any BSc level chemistry book, they are using still capital E, they are using for internal energy. But I am going to use U following the CBSE book. Okay, kindly follow me. Right. Next one. What are the components of internal? When I say internal energy, when I say internal energy, it is indicated by that is capital U, internal energy. What are the components of internal energy? It is nothing but translation energy. It includes translational energy, rotational energy, vibrational energy, Coulombic energy, and interaction energy of constituent particles. All these energy constitute nothing but internal energy. This is the very, very interesting information you must know. Okay, let me go for the next. So when I say internal energy, I have to introduce another term. It's called change in internal energy. So internal energy U, change in internal energy delta U. This is the very interesting information. Kindly follow. The very interesting information is internal energy we cannot measure directly, but change in internal energy can be measured. That's why we have to give concentration for delta U instead of U internal energy. So we have to give concentration for change in internal energy rather than the correspondingly U internal energy. This is the interesting information. Okay. What is the internal energy? Let me give a definition. Thermal changes at constant volume. Thermal changes at constant volume are conveniently measured in terms of internal energy. That is E or U. I already pointed out. I am going to use only capital U, internal energy. And as I already pointed out, it is not easy to measure delta, that is U. So only delta U can be measured. What is delta U? That is very simple. Delta U equal to U2 minus U1. U2, that is internal energy at the state 2, U2 that is final state, and U1 internal energy in the initial state. So that is called change in internal energy. Very, very interesting information. Let us assume this way. Suppose, again, a system is now state A, it is going into state B. It is changing. So initially internal energy is U1, let us assume. The final state is U2. Internal energy for system B is U2. So system A is the initial system, B is the final system. Let us assume. Now the internal energy for the system A, initial state A is U1 and final state B is the U2. So what is change in internal energy? Nothing but U2 minus U1. It is nothing but delta U. This is change in internal energy. Very, very interesting information. It may be anything. State means initial to final state. It may be solid from one state to another state. It may be liquid from one state to another state. It may be gas from one state to another state. Or solid to liquid, liquid to gas, anything. So whatever it is, so energy associated with the final state minus energy associated with the initial state, that difference is nothing but change in internal energy, that is delta U. That delta U can be measurable. This is the interesting information. So, the another interesting information I want to give, kindly keep it on mind. If delta U equal to positive, that is U2 minus U1, then the process will be endothermic process. Kindly follow. It is an endothermic process. If delta U equal to negative, the process will be exothermic process. Very, very interesting information. You must keep it in mind. Okay, let me go for this is regarding for internal energy and change in internal energy. The same way, I can discuss now enthalpy and the enthalpy changes. This is another interesting term in thermodynamic terms we are going to come across. What is the enthalpy? What is the definition for enthalpy? Enthalpy changes measured at constant pressure. Very, very interesting. Constant pressure is called the enthalpy. Kindly have it in mind. Thermal changes measured at constant volume is internal energy. Thermal changes measured at constant pressure is called the enthalpy. Usually represented by H. Very, very interesting. I have already pointed out the enthalpy is not measurable, but change in enthalpy can be measurable. But that's the definition for enthalpy. What is definition for enthalpy? H equal to U plus PV. U plus PV. U internal energy, P pressure, V volume. So what we can know? So automatically, now if you consider H1 equal to U1 plus P1 V1, and same way H2 second state, final state, U2 plus P2 V2. And if you just take delta H, nothing but H2 minus H1, nothing but delta H, change in enthalpy. And if you substitute these above equations, and if you keep the pressure, become pressure constant, automatically you will get this equation. That is delta H is equal to delta U plus P delta V. This is at constant pressure. This is the interesting information you will get here. So, this is the one most important information equation. delta change in enthalpy is equal to change in internal energy plus the product of pressure and change in the volume at the constant pressure. Another interesting equation also we can derive from this. That is, I am getting another equation is delta H equal to delta U plus delta nRT. For if it is a gas, kindly follow me, the change in volume, delta volume, the change in volume can be measurable easily only for gases. Solids and liquids we cannot measure. So for in the case of gases, now instead of P delta V, now I can substitute here delta S equal to delta U plus delta nRT. So that I can derive equally from this equation. PV equal to nRT. This is an ideal gas equations. Substituting these two different gases, P1, V1 equal to, that is N1R T1. The same way P2, V2 equal to N2R T2. So substituting this equation I subtract. So I can derive an equation delta H is equal to delta U plus delta nRT. Delta U, delta H, you know, it is change in enthalpy. Delta U, you know, change in internal energy. Delta N, that is the difference of moles, that is total number of moles of products minus total number of moles of reactants. This is possible only for gases. That is delta N. So R, you know, gas, universal gas constant, T, the temperature. So I am getting two different equations in this case, very, very interesting. One is delta H equal to delta U P delta V. Another is delta S equal to delta U plus delta nRT. This is a very, very interesting equation. You must keep it in mind under the enthalpy chain. Okay. Again, regarding sign conversion, as in the case of delta U, so if delta H equal to positive, the reaction will be endothermic. Kindly follow. So when we are doing any chemical reactions, if the reaction is taking of the energy, absorbing energy, that is, we'll call it as endothermic. Suppose if delta H is negative, energy is released, we'll call it as exothermic. Kindly follow. Very, very interesting information. So from delta H value, we can say whether the reaction is an exothermic reaction or endothermic reaction. So a number of chemical reactions can be classified by measuring delta H value. Very, very interesting information. Next. The another most important thermodynamic term is heat capacity. Kindly follow. Heat capacity, it is not discussed under the Samachir book. So it is discussing only in CBSE. So let me give you a clear idea. Kindly students of Samachir, kindly listen me. What is heat capacity? Normally questions are asked based on the heat capacity in all different question paper I have come across. Right. What is heat capacity? Let me explain. Heat transfers from one system to another. Very, very simple. Heat transfer from one system to another. This heat appears as a rise in temperature of this system when it is absorbed by the system. When heat is absorbed by the system, the temperature is raised. When the heat is released by the system, the temperature is lowered. This is a very easily understandable phenomena. We can understand the concept. So due to heat transfer, whether the temperature will increase in system or decreasing in system. So very interesting information is when the heat is absorbed by the system, the temperature will increase. When the heat is released by the system, the temperature will fall down. Okay. The increase of temperature is proportional to the heat absorbed. This is just now I explained. So that I can give in mathematical form. Q equal to, for microscopic quantity, Q equal to C into delta T. Q, quantity of heat, C, heat capacity, and delta T, the temperature difference, initial and final state of the system. Temperature of the difference in temperature. So, for C is called the heat capacity. Kindly follow. This is the very, very interesting equation we have come across under the heat capacity. So, heat capacity. So, C is the heat capacity. So, what I can write simply, from this I can easily write C equal to Q by delta T. This is a very interesting relationship I can get here. C equal to Q by delta T. Because this is the we are getting, so Q equal to C into delta T, where C is called heat capacity. So if I want to define heat capacity, that is equal to Q by delta T. Thus, we can measure heat by monitoring the temperature rise and C. So heat capacity can be measured what way? By monitoring the temperature rise and also the C we can. This is the most important of life. So by heat supplied if you know and delta T rise in temperature if you know, we can calculate C. This is a very interesting information regarding heat capacity. So I will give some more information under the heat capacity. But I have already found out, so I am now writing in the C equal to Q by delta T. Because we know Q equal to C into delta T, from that equation I am getting this equation. Okay. So I already found heat capacity, C here, is directly proportional to amount of substance. It is directly proportional to amount of substance. So by including the mass of the substance, I can rewrite this equation as C equal to Q by small m into delta T, where m is the mass. Very interesting information. So I am introducing mass there. So when I introduce mass automatically, now I am going to introduce one more term. It is called molar heat capacity. Kindly follow me. What is molar? C, which simply I am calling it as heat capacity. So Cm I am going to use for molar capacity. So molar heat capacity. That's nothing but C by N, where N is the number of moles. Number of moles. So now I can define molar heat capacity as follows. The molar heat capacity may be defined as that the amount of heat required to raise the temperature of 1 mole of the substance by 1 Kelvin. 1 degree centigrade or 1 Kelvin, some here I am calling 1 Kelvin. Let me repeat again. Molar heat capacity usually represented by Cm may be defined as the amount of heat required to raise the temperature of 1 mole of the substance by 1 Kelvin. If the temperature rise is 1 Kelvin for 1 mole, that capacity, heat capacity, we call it as molar heat capacity. This is a very interesting definition we are getting in this. Okay, let me go for the next one. So the same molar heat capacity I am going to express in two ways depending upon the condition. What are the conditions? Molar heat capacity at constant volume. If I am keeping at constant volume, the same heat capacity if I measure at constant volume, so I can now represent CV. CV is the molar heat capacity at constant volume. That will be given by delta U by delta T at constant volume. This is one equation. Delta U by delta T by V or du by dt at constant volume. The same way, molar heat capacity at constant pressure can be given as Cp. Cp is equal to dH by dt at constant pressure. So dx, change in enthalpy, du, change in internal energy, everything we have discussed already. So if it is measured at molar heat capacity, measured at constant pressure, that we use represented by Cp, that Cp is nothing but change in enthalpy divided by change in temperature at constant pressure. Now what is the interesting, very interesting information is, so we are deriving a universal gas constant from these two values, that is Cp minus Cv equal to R. So I can derive this even, but it is not, that is for your level it is not required. So it is not required to derive this equation. But you must have it in mind that Cp minus Cv equal to R, that allows enough. So if based on these equations, number of problems will be asked to calculate. So they will give R value, they will give Cv, Cp can be calculated. The same way they will give Cp and R will be given, Cv can be calculated. This is a very interesting phenomenon. So I have defined now what is heat capacity and what is the molar heat capacity. And molar heat capacity can be explained two ways. Molar heat capacity at constant volume I have discussed. Molar heat capacity at constant pressure also I have discussed. So from this, so Cp minus Cv equal to R, the very most important derivation we are getting under this. So this is regarding for heat capacity. Next, let me enter into entropy and free energy. Gives free energy. Two more important thermodynamic terms I will discuss. Just I will mention because I will come in detail when I am coming for thermodynamics laws. What is entropy? Kindly follow. Entropy is defined as the measure of the disorder of a system. This is a very interesting information. Entropy is defined as measure of the disorder of a system. Order of a system, disorder of a system. What is it? So that is usually indicated by S. Entropy is usually represented by S. I have already pointed out. Normally it is not possible to measure S. What we can it is possible? It is possible to measure delta S. In all the cases, only change in internal energy, change in enthalpy, change in entropy. So change in Gibbs free energy. So only these can be measurable. So the same way, so entropy is defined as the measure of the disorder of system, usually represented by S. Okay. As usual, what is entropy change? So entropy change is nothing but delta S is given by where delta S is equal to Q reversible by T. Q heat absorbed reversible by T. This is the definition for change in entropy. Okay. Now let me give some information regarding what is going to be order disorder of a system to understand entropy. Suppose solid, let us take now solid state. Solid, we have come across if you come across under the solid state, you have an idea that is it is simply arranged in a regular fashion. Simple cubic, face centered cubic, body centered cubic. In a regular fashion, the ions or molecules are arranged, orderly arranged. When you go for liquid, this order will disturb. Go for gases, still it will be disturbed. So when you compare solid, liquid and gas for any substance or any system, now we can say it will be more order in solid state, less order in liquid state and highly disorder in gaseous state. So this disorder is nothing but entropy. So entropy is defined as the measure of the disorder of a system. This is the interesting information. So when you consider one system, one state to another state, measure delta S of the S of one system, initial and final S2. The difference is delta S. That can be measurable given by delta is equal to Q reversible by T. The same way, I can come for Gibbs free energy change. This is Gibbs free energy. This is another important thermodynamic term you must know. What is G? The G is nothing but free energy. Can you follow me? Here I want to give one information. Because normally in thermodynamics, whenever chemical reaction was taking place, previously it was assumed that only delta H was responsible. And later cases in electrochemistry, and Gibbs introduced another most important thermodynamic parameter is G. So using G only we can measure the most important, or the EM of a cell can be measured. That is was proved by Gibbs. So that will be discussing under the electrochemistry. So an idea here it is, Gibbs is another thermodynamic parameter introduced by Gibbs. So it is nothing but related to spontaneity that we will be discussing when I am discussing first law, second and third law. Second and third law I will discuss. The idea here it is, G is another thermodynamic parameter. But as usual, G cannot be measurable. Only change in free energy can be measurable. That is delta G. That can be given by delta G equal to delta H minus T delta S. Delta H, change in enthalpy. T temperature, delta S, change in entropy. So these are the different thermodynamic the parameters, terms we must understand to study the thermodynamics. Very, very interesting information. Okay, with this, let me enter now the next step. That is, now finally, under this entropy change, this is just for your information I am giving. If at all any problem is asked, you can use this equation. If it is an isothermal process, delta S is equal to 2.303 nR log V2 by V1. For isothermal process, delta S is equal to 2.303 nR log P1 by P2. For isobaric process, delta S is equal to 2.303 Cp log T2 by T1. And for isochoric process, the corresponding delta S is equal to 2.303 Cv log T2 by T1. This is the, just any problem is asked. If you know the value, you can simply substitute and calculate delta S. Just for problem point of view, I am giving this. Okay. The next one is kindly follow. So this is the equation I am going to apply. Kindly follow. So I have already pointed out only delta G value equal to negative, it should be spontaneous. If it is positive, it is non-spontaneous. So whether your reaction is positive or negative, then from the delta G value, we can determine whether it is a spontaneous process or non-spontaneous process. So condition number 1, kindly follow. First case, if delta H is negative, first case, and T delta S value, it is positive. So right side, minus into positive, again minus. So delta H is also minus. So automatically more negative. So that particular reaction is spontaneous. So all exothermic reaction generally will be spontaneous. One important information. The second condition, number 2. Second condition. Suppose if delta H value positive, that is endothermic, then if T delta S value, if it is positive, so what we can think of, minus corresponding into minus will be plus. Kindly follow. That means delta H will be plus and corresponding minus, this is also plus. Kindly follow. In this case, again when will be it is minus. The resulting delta G will be minus. What condition? At a higher temperature. At a higher temperature, the temperature is very high, automatically the corresponding T delta values will be very high. So this value, very high value, that this will be plus, automatically minus into plus will be, this minus T delta value will be negative, the delta H value plus, so it will be negative value. The resulting value will be negative, again it is positive. This is the interest, that is the result, this is correspondingly negative, so it is a spontaneous. The condition here it is, the delta G for endothermic reaction, if the delta G value is negative, it will be spontaneous, but only with the condition at the higher temperature, that is T delta S greater than delta H. That is the interesting information. And third condition, if delta H is equal to negative and T delta S value is also negative, automatically this is the delta G will be negative, spontaneous. How it is feasible? At a very low temperature, automatically all exothermic reactions will be spontaneous. So I can generalize now. All exothermic reactions will be generally spontaneous. Right. Coming to the next one, conditions. If delta H is positive and minus T delta H, this value again, it is again negative, then you will minus into minus correspondingly positive. So that means correspondingly the total value will be positive, it is non-spontaneous. Kindly follow, this is the interesting information. So if these values are positive and these values are positive, so delta G will be positive, in that case non-spontaneous. That means in endothermic reaction it is, and the correspondingly this value, that is delta H value should be correspondingly greater, that means, so the total value delta G value plus, it will be non-spontaneous. So let me conclude now. So the idea here it is, if the delta G value negative, spontaneous, again there are conditions, again this is for all exothermic reaction. In the case of endothermic reaction, now again it will be negative, the delta G will be resulting will be negative, only the condition is T delta S will be greater than delta H. Then another case for exothermic, again T delta S value again negative, the resulting effect again negative, spontaneous, but in this is the condition that delta H will be greater than T delta S. And finally, delta H is positive, T delta is negative, the resulting value will be positive, then the process will be non-spontaneous. This is the interesting information. Okay. Now, so with this idea, now I have to enter into laws of thermodynamics. So very, very interesting information. So I hope, so what I have discussed so far, I have given. So what is thermodynamics? What are the thermodynamic terms involved in the thermodynamics I have discussed with a suitable example. Only with this basic idea, I have entered into now the different laws of thermodynamics. 0th law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Okay, thank you.